Hello and welcome to The Deep Dive. You know, sometimes a piece of tech just sort of pops up on your screen right away, and everyone's captivated.
Absolutely.
Lately, for a lot of us, I think that's been the Unitree G1. Maybe you've seen those videos.
Oh, yeah, they're everywhere. Hard to miss.
This sleek little humanoid robot doing these incredible martial arts moves, or like nailing Michael Jackson dance steps.
Right. Or bending over backwards like Neo from the Matrix, basically.
Exactly. We're doing flips in some random living room. It's definitely gone viral. But okay, beyond the stunts. What is this thing, really?
That's the big question, isn't it?
So tonight we're doing a deep dive into this Unitree G1. It feels like it's blurring the line between just being a viral hit and some seriously cutting-edge engineering.
It really is straddling that line.
Our mission is to unpack what makes it so fascinating, look at its capabilities, which seem pretty amazing, but also its limits, and, what does it actually mean for where things are heading?
Well, that viral appeal is undeniable. It definitely grabs your attention. But if we step back and look at the bigger picture in robotics,
Okay.
what we're really seeing with the Unitree G1, which comes from Unitree Robotics in China, is this surprisingly accessible and very capable platform.
Accessible is an interesting word there.
It is, because this isn't just another lab prototype hidden away. It's something more tangible in this fast-moving field of humanoid robots.
Hmm.
And what's really interesting, I think, is the paradox. It's sort of compact, almost playful, in how it's shown off.
Yeah, that doesn't look scary.
Exactly. But it's packed with some incredibly serious advanced tech. And that mix, well, that's what starts these important conversations about accessibility, about how we might actually interact with robots like this in our, everyday spaces.
Okay, so let's dig into that first impression, the physicality. You picture a humanoid robot, maybe you think Terminator, right? Something huge and imposing.
That's the classic sci-fi image, yeah.
Yeah, but the G1, it's, what, about 4 foot 3 inches tall, so 1.32 meters, weighs about 35 kilos. It's really not intimidating at all.
Not at all. It's compact, even kind of portable.
Right. Almost like a robotic teenager or something. It feels more like a potential companion than some big industrial machine.
And that size, that form factor,
Mm.
it's absolutely crucial to why it's catching on and how people see it.
How so?
Well, being smaller makes it less threatening, right? Less alien. It feels more relatable.
Yeah, you can picture it in a room without it dominating the space.
Precisely. And that makes it easier for us to imagine it fitting into our spaces. A home, an office, a lab. It starts to shift how we think about robots, not just tools, but maybe interactive things that could actually be around us.
That makes sense. It's a psychological thing.
It's a huge psychological leap, actually.
Okay, so clearly it's not just about looks. This thing is packed with tech to make those viral videos happen.
Right.
Let's talk degrees of freedom. That's basically how many ways it can move its joints, right?
Exactly. Think of it like the number of hinges or pivot points it has.
The standard G1 has 23, which already sounds like quite a lot for smooth movement.
It is, yeah. But the EDU version, the education or developer version, that ramps it up to potentially 43 joints.
Wow, 43.
Yeah, with extra movement in the waist and the wrists. That's a massive amount of flexibility.
And that extra waist and wrist stuff must be key for making it look so fluid, so human-like.
Oh, absolutely. Game changers for that kind of motion. But what's really critical, I think, are the hands on that EDU version. They're seriously dexterous.
Not just simple claws, then.
No, far from it. They're 3-fingered hands, and each hand has 7 degrees of freedom on its own.
7 just in the hand. How does that break down?
So the thumb moves in 3 ways, and then the index and middle fingers each move in 2 ways.
Okay.
And that intricate setup lets it do incredibly fine motor stuff. It can grip things, pinch small objects, manipulate tools. It genuinely mimics how we use our hands.
Right. I can see how that opens up possibilities, not just waving, but actually doing things.
Exactly. Think delicate assembly tasks, maybe helping in a lab with intricate procedures, or even just handling everyday objects carefully.
Right.
It's the difference between, like you said, a simple claw and, well, maybe not a pianist yet, but much closer.
Okay, so it moves well, it can handle things. What about sensing its environment? It needs to see where it's going, right?
For sure. And it's loaded with sensors for that. It's got depth cameras, 3D LiDAR.
LiDAR, like in self-driving cars.
Yep, exactly, to map the room in 3D. Plus a microphone array, so it can hear, too. Gets a really comprehensive picture of its surroundings.
And connectivity. Needs to talk to the network, I assume.
Definitely. It's got Wi-Fi 6 and Bluetooth 5.2. So pretty cutting-edge wireless for fast data transfer, real-time control, that kind of thing.
So it's taking in all this data 3D maps, visual stuff, sound,
Yeah,
that needs some serious processing power behind it.
it absolutely does. Both models have an 8-core CPU, which is pretty solid.
Okay.
But that EDU version, it offers an optional NVIDIA Jetson Orin module.
Jetson Orin. What's
Sure.
special about that?
Well, for people who don't follow chip tech closely, the Jetson Orin is basically a compact supercomputer for AI at the edge, meaning right on the device itself.
Ah, okay. So heavy-duty AI processing.
Yeah, the kind of power you typically find in autonomous vehicles. It lets the robot process all that complex sensor data and run sophisticated movement algorithms in real time right there.
Even if it's not truly thinking like us yet.
Exactly. That's the key insight here. This level of processing lets it act like a highly skilled athlete following a playbook. It can react incredibly quickly and precisely to a dynamic environment, but it's all based on its programming.
It looks intelligent, but it's sophisticated mimicry and reaction based on the code.
You got it. And understanding that distinction is really important when we evaluate where AI is today. Complex behavior doesn't always equal complex thought.
Right. So it's got the sensors, the brains. What about actual strength and endurance? How long can it run and can it, carry stuff?
Good questions. Battery life is around 2 hours on a full charge.
2 hours? That doesn't sound like a lot for, say, a full workday.
No, and that's quite telling. It suggests it's not really meant for constant 247 operation right now.
Yeah.
More like a drone or a high-performance laptop. You use it for specific tasks or sessions.
Okay. Task specific. Makes sense. And strength.
The standard G1 can carry about 2 kilos per arm. The EDU version bumps that up to 3 kilos.
So enough to hand you a tool, maybe carry some small items.
Yeah, exactly. It's not a heavy lifter,
Yeah.
but definitely useful for lighter tasks. And interestingly, the knee joints on the EDU model have up to 120 newton meters of torque.
Torque. That's rotational force, right? Is 120 a lot?
It's significant, yeah. It gives it the power for those dynamic movements, the jumps, the flips, and helps it maintain stability even during complex actions.
Got it. So agility and power for movement. Now, you mentioned portability earlier, and there's this other really cool physical feature, right?
Oh, yes, the folding. This is pretty unique.
It shrinks down.
It really does. When it's standing, it's 1,320 millimeters tall, remember?
Yeah, about 4'3".
But it can fold itself down to just 690 millimeters, almost half its height.
Wow. That's not just a gimmick, is it? That seems genuinely useful.
Oh, absolutely. Think about storage or transport. You could potentially stick it in the back of a car.
Take your robot to the beach. Okay, maybe not. But moving it between labs or to a conference for a demo.
Exactly. It makes deployment much easier. It's really clever engineering to make it compact like that without sacrificing its performance.
Okay, so it folds, it's agile, it's relatively small. But who is this actually for? Despite the fun videos, Unitree isn't aiming this at consumers yet, right?
No, not primarily. Their main target is research institutions, universities, developers,
Mm-hmm.
people who want to experiment and build on this platform.
Especially that EDU version?
Right. It comes with a secondary development kit. That's key. It lets coders and AI researchers really get under the hood, program new skills, test algorithms.
So it's like buying a really advanced toolkit that happens to walk around.
Kind of. It's a platform for innovation more than a finished product for everyday use right now.
Which brings us to the price. This is where it gets really interesting, you said.
Yeah, this is arguably revolutionary. The base G1 model starts around $16,000 US.
16,000. Okay, that's still a lot of money, but compared to other humanoid robots.
Exactly. Think about Tesla's Optimus or Figure 01. They're mostly still prototypes, and the costs associated are way, way higher, hundreds of thousands, potentially millions.
So $16, while not cheap, puts it within reach for a lot more research labs, universities.
It completely changes the accessibility landscape.
Yeah.
It democratizes access to this kind of sophisticated hardware. More people can get their hands on it, experiment, push the field forward. That accelerates everything.
And you can imagine if it's $16K today for researchers, maybe down the line the cost comes down further, like we saw with computers or drones.
It's the trajectory many people hope for, yeah.
Yeah.
Maybe one day it's much more affordable for wider applications. But it's important we also talk about the limitations right now.
Right. Manage expectations. It can dance, but can it think?
And that's the crucial point. Unitree themselves are open about today's robots, G1 included, lack advanced reasoning, meaning they can mimic movement incredibly well, follow complex programmed routines, react based on sensor input. But they're not understanding the world like we do.
They can't genuinely problem solve in a new situation they weren't programmed for. or understand context or intention.
Precisely.
Yeah.
They don't have that deeper cognitive ability, that flexible intelligence. They are amazing tools performing within their programmed boundaries, but they're not yet thinking partners.
Okay, that's a really important distinction, and yet it's fascinating how we humans react to them anyway.
Isn't it? You mentioned Hanover Mess, the big trade show.
Yeah, what happened there?
People were just drawn to the G1. Instinctively, they'd walk up, wave, shake its hand.
Like it was another person.
Almost. And apparently some people even apologized if they bumped into it. Oh, sorry. To the robot.
Huh. That says a lot about us, doesn't it? We just can't help but anthropomorphize something that looks even vaguely human.
Our brains seem hardwired for it. Even knowing intellectually that it's not thinking, we react on this sort of social human level.
So that psychological factor is huge for how these things might be adopted.
Absolutely.
Yeah.
It's not just about what the robot can do. It's about how we perceive it, feel about it, want to interact with it.
Yes.
That human response will shape everything as they become more common.
Okay, so looking ahead then, if we project this out, where could we see robots like the G1, maybe future versions, fitting in beyond the lab?
Well, once they overcome some of those reasoning and maybe battery limitations,
Mhm.
you can start to imagine them in daily life, can't you?
Cooking, assisting in hospitals.
Potentially. Simple meal prep, maybe assisting nurses with routine tasks like fetching supplies, delivering items in hotels, maybe even certain logistics roles in warehouses.
Things that require mobility and some dexterity, but maybe not deep, complex thought for every single action.
Exactly. Tasks that are repetitive or physically demanding for humans, but within the scope of advanced programming and sensing.
It feels like we're getting a real glimpse of that future now.
I think so. The Unitree G1 gives us this tangible look. It feels like the line between science fiction and actual deployable tech is getting blurrier very quickly.
It's a big step, making humanoid robotics feel more real, more accessible for development.
It's a compelling example of how fast things are moving, bridging that gap from just concepts to machines you can actually, interact with.
So, wrapping up our deep dive on the Unitree G1, it's this really fascinating mix, isn't it? Viral sensations, serious tech, and that surprising price point.
All packed into this compact, agile humanoid form.
It really does give us a clear snapshot of what's coming down the pipeline in robotics.
And, thinking about it, this deep dive makes you consider not just what robots can do, but how we are going to adapt as they become more present.
That human reaction element again.
Yeah. If our brains are already sort of primed to interact with them on this human-like level even now, what kinds of new social dynamics, new rules, new expectations are going to emerge when they're actually integrated into our homes and workplaces?
That's a huge question. How do we navigate that relationship?
It's something we're only just starting to grapple with, really. A fascinating thought to ponder.
Absolutely. Well, thank you for joining us on this deep dive today. Until next time, keep digging, keep questioning, and keep learning.